Hello everyone, I'm Dr. Priya Hassan from the Maulana Azad National Urdu University and welcome to our session on astrobits. So this session, this time, I'm planning to do it on the total solar eclipse of April 8, 2024. Now this eclipse, unfortunately we could not see it from India. It was basically observed from North America, Mexico, Canada. You can see the path over here. It actually goes from the west coast of Mexico and then gradually goes up in a northeasterly direction, crosses the United States, Canada, and then ends at Ireland. So this actually happened in the US, but there's been a lot of coverage on this, and therefore I thought it was an interesting thing for us to talk about. So eclipses basically occur at any time or any place when one celestial body passes in front of another, obstructing the other's light as viewed from a third position. This could also be called a transit or an occultation. And here in this page, we'll also talk about several eclipses that occurred not just on the Earth, but even our solar system. So you can see that this is what happened on April 8th. You had the eclipse. You can see this is called the path of the eclipse or the track of the eclipse. This is the region where you have 100% eclipse. And then there are regions where you have partial eclipses. You can see the percentage marked on the figure over here. And the totality was basically along this strip, which you can see over here. This has been called the Great North American Eclipse, and this was especially an interesting one because at this time the sun was near to a solar max, so people could actually see the sun, more actively compared to the earlier eclipse which was viewed, which was when the sun was not so maximum. So here you can see this is a lovely collage which is made, a composite made of the eclipse from a place called Cleveland in Ohio. This is approximately 2.5 hours of coverage. So you can see here's the solar disk, and here you have the moon gradually coming from here, covering up the disk, and as it covers up the disk, you can see there's a partial, there's the initiation, then it moves over here, and then you have a part which is called the total part, where it totally covers the disk. And here you can see this is a beautiful image where you can actually see the corona of the sun, the outer region, which is at a temperature of over 1,000,000 degrees. This is showing you the activity. And then this is the moment which is considered the most beautiful moment, which is the diamond ring effect, where you have the moon continuing going here, and here you have more sunlight coming from here, looks like a diamond ring. And then gradually you have it covering, and here you have the moon moving out over here, and then you're back to the complete solar disk. So when the moon actually moves in front of the star, of the sun, and blocks its light, it's called a solar eclipse. That's all it is. Now, the apparent diameter of the moon actually varies because the distance from the moon varies, and therefore, if the apparent diameter is greater than that of the sun, a total solar eclipse takes place, like this one, where you can see where the moon has totally covered the light from the sun. But there could be cases when the moon is slightly smaller than the sun, but the moon and sun have an approximate size about half a degree. But like I said, it varies, and therefore, if, for example, the moon does not totally cover the sun, you could have an eclipse which is called an annular eclipse, which you can see over here, where you can still see the ring of the sun over here. It's not totally getting covered by the moon because the moon's size, angular size, is a little smaller. So if you remember in 2019, on December 26th, we had an eclipse which was visible from most parts of South India, which was an annular eclipse, which is like this, where you have this part. But at this time, obviously, the rest of India had a partial eclipse, and you can see over here, this is if you have a total one, there's if you have an annular one. This is from 2019. This is the one from the recent eclipse. And here you can see, this is what I really love. This is a beautiful image of the eclipse from the ISS. This is the International Space Station. And you can see that you clearly have the lunar shadow, the shadow of the moon falling on the Earth, due to which you actually have the eclipse taking place. Now, like I told you, an eclipse is just an obstruction. So you could have something as simple as a transit. For example, in the year 2012, there was a transit which took place where actually Venus, you can see this is Venus, which is moving over the surface of the sun. Obviously, the angular size of Venus is much, much smaller than that is of the sun, and therefore we call it a transit. So you can see that the Venus will actually transit through the disk of the sun, that is, move across the disk of the sun. It actually took 6 hours 40 minutes in 2012 to actually travel along the solar disk. But in principle, this is also an eclipse, but we call it a transit because Venus's size is much smaller than the sun and it actually moves. And here I have a very beautiful image also, which is of This is the NASA rover Perseverance, which is on on Mars. It is on the surface of the Mars, and actually here you can see this is a beautiful eclipse of the sun. Again, a solar eclipse, but as viewed from Mars. Okay, by this rover Perseverance, and basically it's caused by the moon of Mars, and in this case you have it. You have Phobos, which is one of the moons of Mars. Mars has two moons, Phobos and Deimos, and here is Phobos, which is coming in front of it, right? Again, here you can see you don't have a situation where Phobos and the Sun have the same angular size. It's much further away from the Sun, and therefore what happens is here you actually have it only covering partially. But you can see that in this case, you can actually see the shape of Phobos, sorry. And here you can see that the dark patch it leaves gives you an odd appearance. This is basically Phobos does not have a circular shape. And that's because most probably Phobos and Deimos, they are basically asteroids that were caught in the past by Mars gravitational field. And therefore, it's a non-circular orbit, which is causing this thing. So basically what you see is that eclipses are just shadows, right? There's nothing to fear, nothing to be wary of eclipses. It's absolutely a normal thing of blocking of light. Obviously, people did get scared about such things because if you have a solar eclipse, for example, you suddenly have a blockage of light coming from the sun. So just imagine on a day, suddenly if it becomes dark, right? So obviously human beings, animals, birds, everything obviously are in a state of shock. The state of shock could last, say, 4 minutes, 5 minutes, not a very long time, but obviously it would be shocking to suddenly have darkness, which explains why people were so scared and worried about an eclipse, because it means that in broad daylight, suddenly everything goes dark. But in principle, as we understand, we see that there's nothing scary about an eclipse, nothing strange that's happening. It's just that the light is getting blocked, and as this moves away, you again have the solar disk being visible, which basically tells us that that's what an eclipse. There's nothing very special happening to the sun. There's nothing happening to the sun. The sun continues as it is. There's nothing special about the solar light at that time. It's not that suddenly food is going to get spoiled or some kind of radiation is going to come. Instead, radiation from the sun is getting blocked. It's not coming, it's getting blocked, right? And there's nothing strange like that happening, which actually tells us that eclipses are very normal phenomena. If the moon's orbit was not tilted at 5 degrees to the ecliptic, then we would have it actually every month, right? But since there is a tilt, this alignment happens only once in a while with a certain cycle, and that's when we get eclipses. So, thank you and see you next time.